Hi and hello to everyone. In this video, we are going to see about the basic time domain operation on a continuous time signal and a discrete time signal. The agenda for this class is we'll be seeing the operations like time shifting, time scaling, time folding, amplitude scaling, and the combined operations of the above four. Okay, so if you go by the name, what is time shifting? We are going to shift the time, right? If you take a signal, definitely the x-axis would be is a time, right? So we are going to shift the time. We can advance, we can delay. Similarly, we can scale the time. We can compress the signal, or else we can expand the signal in time domain, and we can fold the signal in time domain. We can amplify the signal, that's called amplitude scaling, or else you can attenuate the signal, and we can see the combined operations of the above. Welcome to the lecture. We'll start with the time scaling, right? So this is the signal x of t I'm taking. If you look at the x of t, between the time 0 and 2, the signal amplitude is 2, and between the time 2 and 3, the signal is having a negative slope. Okay, so this is the signal. This signal is given the name x of t, right? So we want to find xa of t, xa of t, right? You can see that this a, if you look at that a, this x is a function of time, and this time is multiplied with a. That means we are working with the time axis. That is your x-axis we are going to work, right? We'll look at two examples. In the first case, we are putting a as 2, a as 2. Okay, so we are going to plot or going to find the signal x of 2t. X of t is given. We are going to find x of 2t. Okay, let us start that. We will start with let y of t equal to x of 2t. We give the signal name as y of t, right, for different instants of time. Okay, first I'm taking t as 0. When I put t as 0, 2 into 0 is 0. Y of 0 equal to x of 0. Then I put t as 0.5. T as 0.5. So t as 0.5, we put x into 2 into 0.5. So it becomes x of 1. So y of 0.5 equal to x of 1. You have to substitute various values of time in this here, right? Thereby we get this. Now if you observe, what you are getting is y of 0 equal to x of 0. What is the meaning? So this is my y of t. Y of t. This is my x of t. Y of t equal to x of 2t. This is what I want to plot. Okay. So what I got? Y of 0 equal to x of 0. So y of 0 is equal to x of 0. So this is coming here. Y of 0 equal to x of 0. Right. Similarly, what about y of 0.5? Y of 0.5 is equal to x of 1. So x of 1 is coming to y of 0.5. X of 1 is coming to y of 0.5. Then what about y of 1? Y of 1 is equal to x of 2. X of 2 is coming to y of 1. Okay. Then look here. What is y of 1.5? What is y of 1.5? Y of 1.5 is equal to x of 3. X of 3 is coming here. So if you observe, this signal which is going from 0 to 3 is getting compressed between the time 0 to 1.5. This is called time compression. Okay, right? This is the way. These are sample points I am taking. Okay, if you know sample points, you can connect, you can draw the plot. Okay. Now if you observe, there is another way of solving it easily, right? Observe the value a. Here a is 2. Only thing you have to do is you divide all the time by 2. Okay, so 0 by 2, 1 by 2, 2 by 2, 3 by 2. Right? That is what here 0 by 2 is 0, 1 by 2 is 0.5, 2 by 2 is 1, 3 by 2 is 1.5. That is another method of getting this plot. Okay, you take the a and divide everything by that a. Right. Next, we are going to plot x of 0.5t. The same way, let us assume y of t equal to x of 0.5t. For various values of t, we get these values. Using these values, you can plot this. Or else, here a is 0.5. So using this 0.5, divide everything by 0.5. So 0 by 0.5 is 0. 1 by 0.5 is 1 by 0.5. 0.5 is 1 by 2. 1 by 1 by 2 is 2. 2 by 0.5, it is 4. 3 by 0.5 is 6. Okay, so the signal is getting expanded. The signal is getting expanded. Okay, right? So what is our final conclusion is, if the signal is x of t is given, if they are asking x of 2t, we have to take this 2, divide all time by 2, thereby the time will be compressed. 0 to 3 is compressed to 0 to 1.5. Similarly, if the a is 0.5, the a is 0.5, what I'm going to do? I'm going to divide this x-axis or time axis with 0.5, thereby 3 by 0.5 is 6, 2 by 0.5 is 4, 1 by 0.5 is 2. So 0 to 3 time axis is going to expand to 0 to 6. 0 to 6. This is called time expansion. So the final conclusion I can make is, if a is greater than 1, if a is greater than 1, then it is compression, time compression. A is less than 1, or a is between 0 and 1. Between 0 and 1, we can say it is expansion. You would have seen this operation in your YouTube or any media player, right? You would have seen, assume a movie is going to run 60 minutes. A movie is going to run 60 minutes, right? If you are going to make it like, there will be an option in the settings like 2x, 1x. 1x is, if you select 1x, the movie will run in 60 minutes. If you are using 2x, the movie will run only for 30 minutes. If you are using 3x, the movie will run for 20 minutes. Similarly, if you are using 0.5x, the movie will run for 120 minutes. Okay, these things you can see in YouTube, right? YouTube, there will be a settings below the video where we can, if you 2x means the movie will run fast. Okay, 2 times it will run. That is called compression. 1x means actual speed. Originally 60 minutes it will run. 3x means 3 times it will run faster. That is 60 minutes movie will run for only 20 minutes. If it is 0.5, 120 minutes. 0.25, 240 minutes. Okay, this you can explore. Next we will see some operation called time folding, right? Time folding is nothing. Here also what we are going to do is, we are assuming y of t equal to x of minus t for various values of t I am putting, thereby I am getting this, right? So if you observe closely, instead of using this expression, still you can do x of t is, if you want x of minus t. So what is happening? Positive time will come to the negative time will come to the positive time. That is called time folding. Or else I can say this is scaling. Okay, look at the previous slide. Here I am using a. Okay, x of at. If you look here, it is x of minus t. So a is minus 1. So divide everything by minus 1. So 0 by minus 1 is 0, 1 by minus 1 is minus 1, 2 by minus 1 is minus 2, 3 by minus 1 is minus 3. So all the signal in positive side will come to the negative side. Similarly, if there is a signal in the negative side, it will come to the positive side. This is called time folding. Next, we will see about something called amplitude scaling. Okay, what is amplitude scaling? Generally, I can say b into x of t. X of t is given. I am saying b times x of t. B times. Okay, suppose example 1 I am taking is 3 times x of t. What is happening? The signal x of t is multiplied by 3. Okay, so if you observe here, between 0 and 2, the signal is 2. The signal is 2. Now between 0 and 2, I am going to multiply with 3. Okay, so 2 is multiplied with 3. So between 0 and 2, the signal goes to 6. Okay. Similarly, the slope also is going to change. Right? That's the concept, right? So it's very simple, right? Amplitude scaling nothing but multiplying the signal by 3. Suppose if it is minus 3, what will happen? 2 will become 2 into minus 3. The signal will come in the negative direction, minus 6 in the negative amplitude. Right? This is called amplitude scaling. Now, what about 0.5 x of t? X of t is given. They are asking 0.5 x of t. So multiply the signal with 0.5. Right? So what happens? 2 into 0.5 is 1. So the signal 2 amplitude now has become 1. Right? So this is called attenuation. What is attenuation? It is opposite to amplification. The amplitude of 2 now has become 1. It is reduced. Okay, x of t is greater than 0.5 x of t is reduced. Okay, this is called attenuation. Right? 3 times x of t is amplification. Right? So if b is, the conclusion I can make is, if b is greater than 1, it is amplification. If b is Between 0 and 1, I can say it is attenuation. Okay. Next, we will see something related with time shifting. Time shifting, right? So generally, I can say x of t, t plus a, right? What is the meaning? X of t is given. I am going to do t plus a. Suppose if a is positive, that is t plus 0.5. A can be negative. I can be giving another example, t minus 1, right? So similarly, if you observe this, pause the video, look at this table. I am assuming y of t equal to x of t plus 0.5. I am putting various values of t, some sample values I am putting. Thereby, I can plot this signal. Okay, first I'm putting t as minus 1. So t minus 1, if I put minus 1 plus 0.5, it is minus 0.5. So simply speaking, it is t plus 0.5. What is the meaning? The signal is advanced by 0.5. X of t is given. Here it is t plus 0.5. So every signal, all the signal is at all moments is going to shifted by zero point 0.5 seconds, right? So observe closely. The signal at 0 will move to advance. This is moved 0.5. 1 is moved 0.5. 2 is also moved 0.5 to the left. Other is advanced. 3 is also moved to 0.5. Okay, so 0 is advanced means instead of starting at 0, the signal will start at minus 0.5. Instead of ending at 3, it will end at 2.5. If you observe closely, you can find that the signal, this signal, this part will be advanced. This is from, you can observe, look at closely where it is starting. It is starting at 0, where it is ending at 3. Instead of starting at 0, it will start at minus 0.5. Instead of ending at 3, it will end at 2.5. Okay, that is, it is advanced time shifting. Okay, I can say this is advanced time. Advanced time advanced is nothing but other way of saying it is shifting left. Shifting left. Okay, if you observe, this signal is shifted left to left of the time axis of how much time? 0.5 time. Okay, next example I'm taking is t minus 1. So t minus 1 is obviously it is delay, right? So instead of starting at 0, the signal will start at 1. Instead of ending at 3, the signal will end at 4. So the signal is between 1 and 4. T minus 1 is okay. So remember, if it is t plus some positive number is there, means it is going to shift the left side, it is shifting. T minus means it is time delay. Time delay, that is shifting right. Shifting right. Okay. This table also will be, this is some basic way of solving, right? I'm forming an expression, then putting some sample value. Need not to be always minus 1. You put any values, thereby you can construct this plot, or else you can use the common sense, right? I always prefer common sense, right? T plus 0.5 means it is advanced, so it is shifted left by this signal is lifted by 0.5 units. T minus 1 is delay, so this signal is delayed to the right by 1 unit. So instead of 0, it is going to start at 1. Instead of 3, it is going to end at 4. Okay. Now we will see the combined operation, right? Combined operation, the example I am taking is 2x into 4t plus 2. 2x into 4t plus 2. See, what are the operations there? Time scaling is there, time shifting is there, amplitude scaling is there. Okay, this 4t indicates time scaling. 4t plus 2, this plus 2 indicates time shifting. This 2 indicates amplitude scaling. Okay, here important point you have to note is amplitude scaling is not a problem for us. We can do amplitude scaling in any order. Only thing, two options are there inside the bracket, right? Whether you have to do shifting first or time scaling first. Okay. The important thing is first we have to do time scaling. Next to do time shifting. This you have to remember. If you change the order of operation, you will get a wrong answer. So first you have to do time scaling, Then you have to do time shifting. Okay, okay, let us start with the first step. What is the first step? The first step is, this is the step 1, this is step 2, this is step 3. Okay, the first step is, we'll start with the time scaling. What is time scaling? First you find x of 4t. What is the concept I have said? X of at means divide all time by a, right? So x of 4t means divide all time by 4. So what I have done here is, I have divided 1 by 4, 2 by 4, 3 by 4. So that's 1 by 4 is 0.25, 2 by 4 is 0.5, this is 3 by 4 is 0.75. Okay, this operation is called time scaling. First to do time scaling. Okay, we have found out x of 4t. Next, we have to do shifting. So x of 4t, already we have found out what is x of 4t. Plus 2. What is plus 2 says? Plus 2 is advanced. Advanced is time shifting. Time shifting advancement, we are going to shift to the left. So this signal, what is the range of the x of 4t? It is from 0 to 0.75. This signal is going to shift to the left. So instead of starting at 0, it is going to start at -2. It is shifted to the left, advanced. 0 is advanced to -2. Similarly, 0.75, if you advance with plus 2, it will go to, just a moment, I think we made a mistake here. It will be like 0.75 minus 2, 1.25. Okay, yes, there's some mistake. I will correct it. Yes. Okay. So this is minus point. The past is correct only. Okay, it should be coming to 1.25. Yes. Yeah. Just a moment. Yes, now it's correct. Okay, we'll see. I'll explain, then I'll draw to you. So 0 will come to -2. 0.5 will come to minus 1.5. If what is the difference between 0.5 and minus 1.5? It is plus 2. Okay, so it is shifted by plus 2, right? So I can draw it like okay, then this will come here. Yeah. Okay, fine. This is what happening. If you observe this, okay, first we are doing time scaling. We are dividing everything by 4. Since we are going to define x of 4t, divide everything by 4, we get this 0, 0.25, 0.5, 0.75. Now x of 4t plus 2. So all the signal is going to the shift left by 2 units. So 0 is coming to -2, 0.25 is coming to minus 1.75, 0.5 is coming to minus 1.5, 0.75 is coming to minus 1.25. Okay, so this is x of 4t plus 2. We have done the second step also. Then what is missing? We have found out x of 4t plus 2. We need 2 times of x of 4t plus 2. So divide everything, so multiply everything with, okay, multiply the entire signal with 2. So instead of amplitude 2, now it goes to 4. Okay, other things are the same. Actually, we have to correct this also based on the right? So it will be like okay. So this is the final answer. So again, I will explain. If x of t is given, the mostly if you take competitive exams, the questions will be like this combined operation, right? Here you have to be very cautious. We have two things. One is time scaling, other is time shifting. First to do time scaling. That is whatever the value next to t, you take that value, divide the time axis. If it is 4, divide all the values by 4. So we did time scaling is over. Then you look shifting. If it is plus 2, it is advancing. So if 2 units, you have to shift the signal to the left. So instead of from 0 to 0.75, everything is shifted to minus 2 to minus 1.25, shifted to the left. This is called advancing. This is called advancing. See, I'm moving towards the left. If it is minus 2, I will move towards the right. Okay, then last step is amplitude scaling. Look, here we have 2 is there, 2 is there, right? So multiply all the signal with 2. So 2 will go to 4, 1 will go to 2. This is the answer. So this is the final answer. Okay. Next, we will work with the discrete time signal. It is very similar to continuous time signal, but the important point is n should be an integer. This n should be an integer. Suppose x of n is given. The signal is from minus 1, the amplitude is 1.5. At 0, it is 2. 1, it is 3. At time n equal to 2, it is 1. At 3, there is no signal. At n equal to 4, it is minus 1. I am going to find x of 2n. What is x of 2n? Here a is 2. Divide all the time by 2. So minus 1 by 2, 0 by 2, 1 by 2, 2 by 2, 3 by 2, 4 by 2. Okay, right. So what is minus 1 by 2 is minus 0.5, 0, 0.5, 1, 1.52. And already I mentioned that n should be integer. N should be integer, right? If you observe, what is 0.5 an integer? No. Is this 0.5 an integer? No. Is 1.5 an integer? No. So we can ignore these three values. I am going to ignore this, ignore this, ignore this. Okay. So what are the remaining values present? At 0, what is the signal? At 0, the signal is 2. So I have drawn here at 0, the signal is 2. At 1, what is the signal? 1. At 1, the signal is 1. At 2, what is the signal? It is minus 1. Okay, this is called time compression in discrete time signal. Okay, remember, same as that of continuous time signal, but this n should be an integer. If 0.5, 0.5, 1.5, they are not integer, so we are removing those signals. Okay, we are keeping only the integer signals at 0, 1 and 2, right? Suppose if I say x of 0.2n, so what do you do? You divide everything by 0.2. Thereby you have to take only the integer values. Remember, this n should be always integer. That is the important point to remember. Okay, then we are going to do about something called time shifting. This is straightforward. X of n is given, x of n plus 2. That means I am going to shift the signal. How much time? 2 units to the left. This is called time advance. So minus 1 will go to minus 3, 0 will come to minus 2, 4 will come to 2. Okay, so this entire signal is moving to the left by 2 units. Okay, that's what around here. N minus 3. What is happening? The signal will be delayed by how much time? 3 units. Instead of 4, the signal will go to 7. Instead of starting at minus 1, it will start at plus 2. Okay, this entire signal is shifted to the right. Okay, this is right shift. Delay means right shift. Advance means left. Okay, again remember n should be an integer. Of course, for time shifting and all, there won't be any change in n integer or non-integer values. Only for time scaling, as you looked in the previous case, we are going to take only the n as integer values. Okay, this is a problem I am giving as an workout example, workout for you. A signal is given. The question is find x of t plus 1. Okay, what is t plus 1? Yes, it's advanced, right? You are going to advance the signal. Advancement, what is the meaning? You are going to shift the signal to the left. By how much unit? 1 unit. So what is the range of the signal? It is from -2 to 4. It is from -2 to 4. So because of plus 1, what is going to be minus 1, 2 will go to -3, -1 will come to -2, 4 will come to 3. So this entire signal will be shifted to the left, will be shifted or advanced to the left by how much unit? 1 unit. Okay. Next, what is x of 2t? What operation this is? This is time scaling. Take this to divide all time by 2. Okay, so signal will get compressed. Now what about this? Here a is 0.2. Divide everything by 0.2. So -2 by 0.2 is what you'll get? It is -2 by 0.2 is 10, -10. Okay, so 4 by 0.2 is 20. So minus 10 to 20, the signal will be expanded. Okay, take this, simply speaking, take this point to divide everything by 0.2 and find out the last value, find out those, put those values. Okay, thereby you will get the time expansion. Here x of 2t already we have found out. Multiply the answer with 3. Amplitude scaling. So 3 will go to 9, -2 will go to -6, 1 will go to 3. Okay, rest all you can figure out, right? Then this is very important. X of minus t plus 1. Minus t plus 1. What about this? Minus t plus 1, right? Understand the difference between t plus 1 and minus t plus 1, right? Here, there is an time scaling of how much value? -1. So first to do, this is very, very important. Most of the students will make a mistake here. First operation should be, first you find out x of minus t. Then with this answer, you make it to then advance by plus 1. Plus 1 means what is the meaning? Left shift. Okay, suppose you are changing it. First you are doing t plus 1, then we are folding. That's the wrong answer. Okay, first to do scaling, here a is -1, so divide everything by -1. So -2 -1 will become 1 and 2. 1 2 3 4 will become -1 -2 -3 and 4. The signal will be time folded. Positive time will go to negative, negative will come to the positive. Now you will do the shifting operation. That signal you shift it by plus 1 unit, that is left shift or advance. Okay, right. Look, last one, right? First you have to do 3 by 4 time scaling. Divide all the time by 3 by 4. Then you do plus 2. Then shift it by plus 2. That is advance by plus 2. Then you multiply the entire signal by 2. Amplitude scaling. First to do time scaling, then time shifting, then amplitude scaling. Okay. Any doubts, ask in the comment section. Do subscribe the channel. Wish you a happy learning. Thanks for listening. Jai Hind.